This problem calls for the 4 statistical results after entering a list of real numbers. So it is tempting to lean towards using something like a list or an array in order to solve this problem. So for instance, you would have your numbers like 5.5, 4.4, 2.2, something like that. And you would key them in, and then ultimately you'll key in a 0 at the end to halt the entire process. If you built up a data structure like this as you keyed in the numbers, number one, the computer will have to allocate quite a lot of memory to hold the numbers. And if this program were to be used on a large scale project, such as working through a very, very large data set of weather statistics, such as temperature readings and so on, it would be quite heavy in terms of demand on the computer's memory. Secondly, working through the numbers a second time in order to derive the statistical results that we're looking for is also going to be very time consuming. So there is another way to look at it. If we had some variables in existence already, let's begin with one called highest, and we set it equal to 0, then each time that we iterate, each time that we invite the user to type in a number, we check and see, well, is the highest value still the highest value now that a new number has arrived? And in this case then the 5.5 would be used to update the highest variable. Secondly, we key in 4.4. That would be compared with the current highest, and it would be ignored because there's no need to update the highest value. And then 2.2 would come along, and again there would be no need to update it. That would mean that we wouldn't have to store all of the values, we would only have to store the highest value as we went along. We could simultaneously store the lowest value by starting with a very, very large number. We could type in some sort of extremely large number as a starting point. The size of this number will of course depend on the reality of the data set that you're dealing with. If it were to be temperature statistics on planet Earth or whatever, then this kind of temperature is not going to be realistic. It's not going to feature in the data set. So you start off with something very, very high, and then by following the algorithm, each time you iterate through, you say to yourself, well, does this number still represent the lowest value? And if it doesn't, then you're going to update it. So it'll straight away become 5.5, and then on the next iteration it will change to 4.4. On the next iteration it will change to 2.2. Ideally, we will set this up in such a way that it doesn't accidentally update to 0 whenever we type in 0 to end the iterations. So if we use this approach, finding the sum of the numbers should be fairly straightforward. And if we initialize the sum variable to 0, all we have to do each time is just update the sum so that it adds the number that has just been keyed in by the user. Calculating the mean is a different matter, because the mean shouldn't really need to be calculated until the very last minute. So in order to know the mean, we're going to have to know how many values were entered. And if we're not going to be saving them in a list, then we're going to have to keep a rolling total of how many have been entered. So we're going to call this one quantity, and we'll start it off as 0, and you'll notice that this is the only value that will be in integer form. Okay, proceeding with this approach to the solution, we can now begin to think about, well, how will we do the reading in of the values? Since we know that we are going to be reading in at least one value, even if it is a 0 immediately and the list actually is empty, we know that we're going to be doing all of this work at least once. When we're going to be doing work at least once, that lends itself to a do-while loop in Java, which has this syntax. Okay, so the do-while loop is going to begin by allowing the user to key in a value. So let's get ready for input. Okay, so to get ready for input, we are going to introduce the scanner class. I'm going to say keeb equals new scanner. Keeb is the name of my scanner. It's connected to the console input stream, so we'll say system.in. Scanner is not recognized immediately. That's not a big deal. We're going to let the NetBeans IDE help us here and just add an import statement for us up at the top here, and that's for reading in numbers. So having now built the scanner variable, we can now make use of it inside our do while loop. The first thing that we're going to do is use our scanner to read in the value that we want. If we use the the NetBeans ID is a bit slow sometimes with this, so if I just do it a few times it will eventually kick in and help me. I want to know the next double. So I want to know the next double. I want to know the number that is keyed in by the user, and I'm going to store it in a variable. So in order to get ready for input, I'm going to build a number. I'm just going to call it real so that I know what the real number is. So my real number that I have just read in has been read in as a double. Next, we're going to now perform the various updates that we need to perform. Let's consider the highest, okay? So let's update the value of the highest number. If the number that we have just read in, which is called real, is greater than the existing value of the highest number, then, just scroll down to create some more room, then that means that we are going to have to update the value of highest. So the value of highest is now going to be overwritten by the value of the new real number that has just been keyed in. We're going to follow exactly the same approach in order to update the value of the lowest number entered so far. Changing the word high to the word low in these various places here, here, and here. And then reversing the greater than symbol to a less than symbol. If the real number that has just been keyed in is less than the lowest number that we've got so far, then we update the lowest variable. Thirdly, we can now turn our attention to the sum of all of the numbers. We have a variable called sum that we can now update. This doesn't require an if statement, so we just say that the sum plus equals the real number that we have just keyed in. Finally, we're going to increment the number of numbers that have been keyed in. We're storing this in a variable called quantity. So a handy way to do that in Java is to use the increment operator, the double plus. Now that all 4 of our statistics have been updated, we now say to ourselves, it's time to read in the next number. The next number can be read in by taking the same line of code again. So that's obviously going to happen during the do while loop if we keep going round and round. So having now done all of our updates, we're going to keep doing this while the real number is not equal to 0. Now we could write it in real number notation, or we could write it in integer notation, but either way, an implicit typecast is going to take place if we are dealing with the number 0. So just to be correct about it, the real variable is of data type double, therefore we're going to express it in data type double, and even if the number 0 is entered as an integer, the scanner is going to convert it anyway into the double data type. Okay, so taking a step back and looking at the code that we've got so far, we see that if we were to enter in our first ever number, the first ever number will be entered in here, and then we will proceed straight away and we will update all of our variables. However, if at any point we enter the number 0, we would prefer that we would bypass all of this work and that these various steps that have been highlighted do not actually take place. So on that note, we're going to put in an if statement here and say if real is equal to 0.0, then we're not going to do any of these things. So that should probably be expressed as if real is not equal to 0.0, we're going to start doing all of this work all the way down to here. We can now right click and say format to allow the NetBeans IDE to perform the indentation for us so that we don't have to. So we're going to read in our first ever number. As long as it's not a 0, it will bomb on ahead and do all of the work, and then it will keep doing that while real is not equal to 0. So it'll read in another number. As long as it's not 0, it will then proceed and do another round of updates, and it will keep going as long as we haven't entered a 0. Finally, after the do while loop has fully completed, it's now time to present our findings. So we can proceed now with calculating all of the values that we need. For convenience, let's take a copy of the values that we've got here and paste it down here. So the value of the highest can now be output by doing system.out.println, and we can say highest, H-I-G-H-E-S-T. We can use the tab character a couple of times, and then we can concatenate in the value of highest. In the Java language, that will implicitly typecast that real number into string format. Secondly, we can do the same thing for the lowest value. We'll just take a copy paste of this syntax. We'll cut the variable name into there, and we'll change this to say lowest. Thirdly, we'll want to know the total. So we'll take another just copy of these pair of lines of code to save some typing. Okay, if we want to know the total of these numbers, then it should be able to output the total. I think I called it sum actually. And finally, we want to know the mean. In order to work out the mean, well, we already had a variable called mean, and what we can do is we can simply calculate the mean here. We'll put it in as a bracketed expression, and we'll take out the use of the variable called mean. We'll say that it's not used. Okay. So if we want to calculate the mean, then we take the sum of the numbers and we perform real number division by the quantity. Since this is a real number and this is an integer, it raises a question as to what type of division will take place, and the answer is real number division will take place, and we will end up with an answer expressed as a real number. So considering how we're going to test this, we can now put in some expected outcomes. Copying down the list from above, we had 5.5, 4.4 and 2.2 as our numbers. Let's modify this slightly, so let's make it so that they're nice easy numbers to work with by saying numbers that will add up to numbers that can easily divide by 3. So we're expecting then that the highest value is going to be 5.5. We're expecting that the lowest value is going to be 3.3. We're expecting that the total is going to, the lowest value is 1.1. We're expecting that the total value is going to be 9.9. And we're expecting that the mean is going to come out as 3.3. I'll just actually change that up above as well, just to keep it consistent, just as a line of thought. Okay, so what we're going to have now is a quick run through of the program running with these values. So if we say just run up here, okay, so we type in 5.5, we type in 3.3, and we type in 1.1, and it gives us out and 0 to terminate, and then it should give us out our answers. The highest is 5.5, the lowest is 1.1, the total is 9.9, and the mean is 3.3 with the dreaded imprecise representation of real numbers in the language. This is to do with base 10 and base 2. Computers work in base 2, we think in base 10. The two number systems don't marry up very well. Computers have to store real numbers as approximations, so it creates a little bit of a problem. Something I'm not happy about in the program is that the user is not prompted to type in input, so that's an area for improvement that shouldn't take too long to fix. So what we'll do is each time that we're about to invite the user to type in a number, we're going to use system.out.print. We'll not take a new line, and we'll just say enter a positive real number. Do a colon, leave a space, and yep, that should be the only place that occurs in the program. Yep, I think we're good. Okay, so if we rerun this this time and enter positive real number 2.2, 3.3, 4.4, and then 0, it does come out with the expected outcomes. Again, we've deliberately chosen numbers that will add up to 9.9 just for an easy life, because we know that that's easy to divide by 3. Here is another run of the program, and the only difference this time is that the numbers have been done in kind of wildfire style, and the only thing to point out here is that the lowest this time, because it was quite a small number, NetBeans has output it using scientific notation, standard form, as 9 multiplied by 10 to the power of minus 4. Minus 4 is an exponent, so that's what the E stands for. Okay, I'm happy with that as a solution to the problem.